Sir, good evening, sir. This is K. Pranavi. My roll number is 234G1A0488, and I'm from the ECA section. And my topic in the chemistry and this presentation is about the potentiometric and amperometric sensors. So let us see what is about this potentiometric and amperometric sensors. So as we are seeing in the outline, there is introduction and we are going to get to know about what are the potentiometric sensors and what are the analysis, like where they are used in the real lifetime and what are the applications and what are the amperometric sensors, analysis, applications, and at last but not its conclusion. So introduction is in this presentation we'll learn about the potentiometric and amperometric sensors and their applications. What are potentiometric sensors? Potentiometric sensors is a type of chemical sensors used to determine the analytical concentration of components in a solution or gas. In keeping it in an easy way and to understand easily, let's say that potentiometric sensors are used to know what is the potential difference between the two electrodes. Like when we use the when we dip those two electrodes in the titrate or any solution, then we'll get to know what is the potential difference between those two created. So for those we use the potentiometric sensors. They work by measuring the electrical potential of an electrode when no current is flowing. This potential difference or voltage is measured between a working electrode whose potential depends on the analyte concentration and a reference electrode which provides a stable reference potential. So as we see here, working electrode, we consider glass electrode as a working electrode here because it detects the H plus ions in the solutions. And as for the reference electrode, we may consider like caramel or something. These sensors are classified into three broad groups. It takes another session if we go into these three broad groups. So let's see what are the analysis of these potentiometric sensors. So this is the brief diagram of potentiometric sensor. Here we see this reference electrode and working electrode, and we connect these both to the potential state, which gives us the value. Here the chemical reaction takes place, which gives us a electrical signal. These are called sensors. Like potentiometric sensor or maybe amperometric sensors, these take the chemical reactions takes place, and it is converted and gives us in a form of signal in the form of an electrical form. Analysis of a potentiometric sensors. When we get to about the analysis of potentiometric sensors, the first thing that comes to in our mind is glucose. So in the glucose, like to detect how much percentage of glucose is in our blood these days, potentiometric sensors are widely used in that. So this glucose is oxidized into gluconic acid, which is further undergoes decomposition and gives H plus ions, which are detected by the pH electrode. pH electrode nothing but glass electrode, because glass electrode detects the H plus ions, which in turn gives the pH value. So as we see here, the equation glucose plus O2 in the presence of glucose oxidase gives us a gluconic acid plus H2O2. H2O2 is nothing but peroxide. This H2O2 again, when near the electrode, it splits into the ion, that is 2H plus O2 plus 2 electrons. This H plus ions measured by pH meter, a potential difference is set up between the glass reference electrode, which is sensed by a potentiometric sensor, which analyzes the glucose level in blood. As I told you that these potentiometric sensors use by this method, like in this type of formation is happened in the when in this so by this method we'll find what are the glucose levels in our blood. What are the applications? Potentiometric sensors are broadly used to measure position, displacement, level, motion on so many, etc., and other physical parameters. They are also integrated into other sensors to monitor chemicals, gases, or biocides. What are amperometric sensors? As we know about the potentiometric sensors, amperometric sensors is a little bit different from the potentiometric sensors. That is, it also takes place in the chemical reaction, but the electrical signal it gives is in the form of the current flowing in between the two electrodes. So, amperometric sensors are self-contained integrated devices that measure the current flowing resulting from the oxidation or reduction of an electroactive biological element. But the thing in this amperometric sensors is, in amperometric sensor, redox reaction takes place between the analyte and the electrodes. The sensor typically consists of a working electrode, a reference electrode, and an auxiliary electrode. Few of the amperometric sensors contains only two electrodes, that is working and reference, but few of the amperometric sensors contains three electrodes. The working electrode is coated with a material that selectively interacts with the analyte of the interest. When the analyte undergoes oxidation or reduction at the working electrode surface, an electric current flows which is directly proportional to the analyte concentration. This is the brief diagram of an amperometric sensors diagram. As we can see, here is a reference electrode, here working electrode, here auxiliary electrode. These two are connected to the amperometric detector. Here we will find what is the current between this. And in analysis of the amperometric sensors, we use the analysis of uric acid. Uric acid plus water plus O2 in the presence of urease enzyme will get this alanine and plus H2O2. H2O2 is again oxidized, which gives 2H plus O2 plus 2E electrons. H plus ions are detected by the glass electrode. The produced electrons flow on the circle as they develop current between two electrodes. It will detect the current which produces electrical signal. Applications, biomedical applications. These sensors are used to transmitter detection, enzyme assays, and monitoring biomarkers. Food industry. Amperometric sensor access food quality by measuring specific components. Example, lactate, ascorbic acid, or ethanol. Process control. They play a role in industrial processes such as fermentation, where real-time monitoring is essential. By the end of this presentation, we learned whatever the potentiometric sensors, amperometric sensors, and where they are used, and the analysis of both sensors, and how we use them in our real life. So, thank you.